So in this problem, you are given a simple directed graph with n nodes, labels from 0 to n-1, and the graph would form a tree if the edges were bidirectional. And an edge reversal means going from u to v to u. And then you need to return the answer of a size n, where answer index I means if node I is the root, how many edge reversal that we are required to do so that the node I can reach every other node. So let's take a look at the example to illustrate the idea more. So in this example, n equals 4 and edges is 2, 0, 2, 1, and 1, 4. So if we visualize the input, the graph will look something like this. And the output is 1, 1, 0, 2. Let's take a look why 0 first for 2. So as you can see, for node 2, you don't have to do anything. You can automatically reach every other node, so that's why it's 0. And for node 0, which is this node, what we need to do is to just reverse this 2, 0, and then reverse it to 0 to 2, and then we can reach everything. So we just need to do one reversal, and then 0 can reach everyone else. And for node 1, if we reverse this edge from 2 to 1 and make it from 1 to 2, and it will make 1 reaching everyone else. And finally, for node 3, you have to revert this 1, 3 to 3, 1. That's the first step. But even if we revert it, we still have to do this 2 to 1 to 1 to 2 in order to reach everything out. So that's why we need 2 reversal. So that's pretty much all for the explanation for the problem and example, and let's see how can we actually solve it. So first thing we want to do in this kind of problem is to treat a random node as the root, and it can be node 0 or it can be node 2, whatever. In this case, I would just assume node 2 as the root of the tree because it is mentioned that the given graph will always be a tree if I ignore the direction of the edge. So I'm just going to choose 2 as the root and see how many reversal we need in order to make 2 reachable, which in this case, the cost for 2 to reach everyone else is 0, but it could be not 0. For example, if this edge was from 1 to 2 in the input, and it will be 1, but let's just say it's 0, or assume that it is something like A, which is the cost to make root reachable to everything else. By root, I mean just the random node that you choose at the beginning. This is going to be extremely helpful to us later because if you think about it, when you're trying to assume that this node is the root, then what cost do we need to do? Obviously, we still need to do all the reversal here. For example, if there is something like this, then we still need to reverse this stuff. So that's why we still need this cost from the root. However, the only thing that changed is the path from the root to the current path. If I'm trying to assume cur is the root, basically if I'm trying to answer how many costs that we need to reverse in order for free to reach everything, first I need to know the total cost from the root to reach everything else before. And also the only thing changed is before it take like 0 cost to get from 2 to 3, but now if I change 3 to be the root, if I calculate the depth of 3, it will be 2. So originally the depth of 3 is 2, and then it takes 0 cost going from 2 to 3. It means that every edge from 2 to 3 is not reversal. So that means that if we want to go from 3 to 2 back, we need to do depth cur minus inverted cur. That would be the only cost that changed. Basically the path from the pseudo root that we choose to the current. So to answer I, which means if we treat node I as the root, how much do we need to reverse is A. This A is coming from here, is just the total cost from our pseudo root to reach everything else. We still need to consider that, but the only thing that changed is the path from the root to current itself. And after changing this path, and you can see this 3 can reach everything else. So that's why we only need to pay this path apart from A. So A minus the old cost. The old cost is the inverted path that from root to current that need to pay, because now we try to reverse it, there's going to be a new cost. So this old cost, we can just minus this O cost inverted, which means how much that it takes from root to current, which we can calculate it using DFS pretty easily. And you minus the old cost and plus the new cost. The new cost is the depth of current, which means how many steps that it takes from root to current minus the inverted curve. And that's pretty much how we can calculate every answer I in a very efficient way. And that's pretty much all for the solution overview. And let's see how can we actually implement it in code. So first, I'm just going to create an adjacency list to record what is the neighbor of each node if we don't care about the direction. And we also need to create another data structure called connected, which means if we consider the direction and is A really connected to B. So we need both because sometimes we need to know if we need to do the reversal or not. And the depth just means how many steps does it take for root to reach that current. By the way, root will be 0, but it can be any node in the tree. Causes means how many edges need to be reversed in order to reach node I from root. And now we can start filling our adjacency list and connected list. So for every edge, U and V, and adjacency U at V, and also adjacency V at U, because again, adjacency list on line 6 does not care about the direction, and we will need that information later, but we will use another data structure called connect. Basically, if connected U has V, it means that it is really connected if we consider the direction of the edge. And after that's done, we can create our DFS. So the first parameter is the current node that we're visiting. Parent is the parent that visit this current. And then inverted means how many edge has we reverted at this point. And depth means how many steps does we take so far. So this DFS will return the number of edge that it needs to take in order to reach all children. So first of all, we're going to initialize result as 0, and then we're going to go visit every neighbor. If that neighbor is parent, then we're just going to ignore that in order to prevent infinite loop. And if neighbor is not in the connected, but it is in the adjacent, it means that they are connected, but we need to reverse the edge. So if we want to reverse the edge, of course, we need to add 1 to our total result. And also we need to add revert plus 1 because again, we need to spend 1 cost in order to reach this neighbor. And depth is plus 1 because we take 1 more step, and otherwise it means that we don't have to revert anything to reach there. So that's an easy case, and we will just f plus 1, but inverted stay the same, and we mark current as the parent, same as line 21. And then after that's done, we want to record the causes. Basically means how many edges are inverted in order to reach current, and then we can store that value on line 24 and on line 25. We will also keep track of that we're going to use later, and then we just return the result, which means the total edge that we have inverted in order to reach all children. And now that we can start calculating our final answer, we initialize that at an empty array. And A means the total cost from the random root that we choose, which is 0. So it is 0, and then the parent is -1, it means there's no parent, and then inverted initialized as 0, and same as depth initialized as 0. And then for every node, then the new cost path is the depth minus the previous cost, which we have explained in detail in the solution overview. And then the current cost is A, which means the total cost for root to reach everything else, minus the old cost, or old path cost, plus the new cost. And after that, we can just append this current to our answer and eventually just return answer. Okay, so the time complexity is ON, basically coming from iterating all the edges, because it is given that the graph will be a tree if it is a bidirectional edge. So the edges will have a length of n-1. And also we will iterate every node in this DFS, and also this loop will loop n times. So that's why for time complexity with ON, and space complexity is ON as well, basically coming from this adjacency list and cost and depth, etc. So that's pretty much all. Let's try to submit it. Okay, accepted. Again, I will post the text version of the solution in the description box below, and thank you so much for watching, and I will see you next time. Bye bye.